Okay, can you hear my voice? Dengar suara saya?
Yes, sir.
Okay. Okay, so let me share the slide. Okay, so let's continue our lessons on the next we will okay, we will look on the terms of chapter 3. Okay, I believe that all of you have looked at the chapter 1, so this is chapter 3. Okay, actually we have started the chapter 3 yesterday, but I want to recap a few things about vectors and scalars quantity. Okay, a scalar quantity has only magnitude. They have magnitude, and while vector quantity has both magnitude and directions. Okay, so this is the examples of scalar quantities I will compare to vector quantities. So what is actually vector quantities? So vector is actually a measurement, okay, a measurement with the directions, okay, measurements with the directions. All right. Okay, so we can see how can we represent vectors by using the arrow. Okay, so it's either arrow or maybe using a bold alphabet like this. Okay, a bold alphabet. Okay, it's hard to explain about bold because I'm typing right now. So actually, when you see the alphabet with the bold, and sometimes you can consider to be a vector. Okay, and how about the alphabet with the arrow, okay, on top of the alphabet? So that is also considered as vector. So that's how you differentiate between a scalar quantity and vector quantity. If the vector, we want to say this is the vectors, we should put the arrow. Or maybe we can use italic like this. Okay, or sometimes we can represent it by using a bold alphabet. Okay, so this is the equality of the vectors. Okay, same length and same direction. That is how we can say that the vectors is equal. And then we also learn about how to add vectors in terms of graphical. Okay, graphical using lukisan. Okay, but that is not a normal drawing, but we should draw the vectors with the accurate values. That means sometimes the vectors can be represented by the ratios. Okay, for example, 1 centimeter to 1 meter. So it is hard for us to draw a vector of 5 meters. Okay, in fact, we only have like a size of A4 paper only. Okay, so how can we draw a 5 meters on the A4 paper? So it's very hard to understand that. So that's why we need to use a ratio. That means 1 centimeter will be equals to 1 meter. So you can draw 5 centimeters to represent 5 meters. Okay, so this is how we use how to add the vectors in graphical. We use the tip to tail method. There is other. I forgot to mention that there is other ways to draw a vector that using the what we call that as a parallelogram. Okay, another parallelogram. Okay. How is possible can we draw a parallelogram? For example, that we want to know what is the resultants of vector A and vector B. So first we draw a vector A like this. Okay, this is not how we draw. You should draw a vector S because I'm using a freehand. Okay, we should use a ruler, and of course we need to use some protector, one so on. Okay, so basically the tip-to-tail method, if we continue to draw a vector B at the end of vector A, that means here. Okay, this is vector A, and then at the end of vector A, we put some imaginary arrow like that, imaginary axis like that, and then we draw vector B at the end of vector A. Cool. So in order to that is how we do in tip to tail method. Okay, but it's another method is will be parallelogram. So how can we draw a parallelogram? So the difference between parallelogram and the tip to tail method is parallelogram will draw the second vector. Okay, how? We draw the second vector at the beginning of vector A. At the beginning of vector A. That means, okay, we put that imaginary at the beginning of vector A, and then we draw a vector B. So this is vector B. For example, this is vector B. And then, okay, of course, we want to know, we can draw a parallel to the vector B will be here, and the parallel to vector A will be here. And then we can see the resultant vector will be at the parallel between the two vectors. That means here, this is R. And if you can see this R, okay, that means the vector should be correct in what types of method that we are used. If we use the tip to tail method, because of course this is tip to tail method, and this is parallelogram. Okay, so both are we can say that both is both directions of resultant. It is quite the same. And of course, if we can measure if we are using the right measurement, if we do it properly with the use of a ruler, of course, then we can always have the same measurement of resultants. But the parallelogram we can only use parallelogram when there is only two vectors to be added. Okay, if we have let's say here the second category, that means you have vector A, vector B, vector C, ada 4 kan, 1, 2, 3, 4, boleh tak guna parallelogram? No. Okay, because we can use a parallelogram only for two vectors, A plus B. Okay, that's why it didn't mention here about to use the parallelogram. Okay, so this is how we did adding of vectors in the graphicals. Okay, that means we are using a ruler and protractor. Okay, so if you see the value is 8.75 by using a ruler, okay, we just measured it with 8.75, and the theta, okay, use the protractor to find the angle. The angle where is between the resultant, that means this color, this line, okay, and until the x axis. So this is theta equals to 45 degrees. Okay, right. Okay, this is the sum of vectors. Vector A plus vector B will be equals to vector B plus vector A. Okay, if we use a tip to tail method, okay, if A plus B, that means at the end of vector A we draw vector B, and if there's a vice versa, so B plus A, that means at the end of vector A, okay, we add a vector. At the end of vector B, we add vector A. Okay, and if you see, we can have the same resultant vector. That means the measurements, okay, the length, and the directions of vector resultant will be the same. Okay, it cannot be different. Okay, how about subtracting? As I said to you, the subtracting is actually based on the negative value. Okay, if A minus B is equivalent to A plus vector A plus vector negative B. So that's how we know. What is vector negative B? That means the directions of negative B is in the opposite directions of vector B. If the vector V is going upwards, that means this is vector B. So vector negative B will be the same length as vector B, but on the opposite sides of vector B. That is how we differentiate between vector B and vector negative B. Okay, that means the subtracting is actually a plus, but we should know the negative comes from the negative of B. That means the directions of vector B. Okay, this is how we did some examples in order to understand the concepts of vector. But if we're using a graphical, that means the best way to calculate it, or the best way to understand it, maybe you can also use a graph paper, okay? Because the graph paper already has some a box, so you can use the box, okay, to understand how, because sometimes 1 centimeters is equivalent to let's say 1 kilometer, 1 meters, okay? So it's easy to use a graph paper. Okay, so right now we want to know about how can we calculate vectors. Okay, this is much more complicated compared to graphicals. Okay, because in this part, okay, we will learn about components of vectors. Okay, I believe that all of you already learned about components of vectors, because all vectors, okay, regardless if you look carefully at how the vectors is created. Okay, for example, this vector. Okay, if you look back, this vectors comes from, okay, let's look at vector C. Vector C, okay, vector C is come from is created using vector A and vector B. That means if you want to get the components of vector C, that means we can have vector A and vector B. But how can we show in these situations? Okay, because C comes from A plus B. So in order to get a components of C, we need to get A and B all together. Okay, so this is how you should understand that. Okay, so the very easy way to understand the vectors of the components of vector is like this. Okay, if you have vector A over here, okay, at the vector A, okay, the vector A must come with the two other axes. Okay, must come with the two other axes, which is vector A in terms of x-axis, noted that as AX. And also vector A in terms of y-axis, which is noted as AY. Okay, if you look carefully, AY and AX doesn't have an arrow. Okay, A have an arrow, that means that is vector A. Okay, but AX and AY is the components of vector A. That means if you want to create a vector A, we should do something to vector AX and AY. Because AX and AY, if we do something to AX and AY, we get vector A. So based on that particular if we look carefully, the theta is between the theta is between the theta is the angle between vector and x-axis. Okay, this is x-axis, right? So the angle comes from that part. Okay, so if we are using a simple trigonometric function, okay, how to get something from here? Okay, so if we can know that this is vector A, okay, vector A, so let's say we don't know what is the component of both. We just know this one is x and this one is y. So I will use another. So this part is angle theta. Okay. So first we use some trigonometric function over here. So that means cos theta. Okay. So this is ax and this is ay. Okay. So the cos theta is equivalent to what? In terms of trigonometric function, cos, okay, SOHCAHTOA, okay, is opposite over adjacent over hypotenuse, okay, because this is hypotenuse, this is the adjacent, okay, and this one AY is considered to be opposite. Okay, what is cos theta? Cos theta is AX over A. Okay, AX over A. So in order to get A, AX is equivalent to A cos theta. Okay, and this is cos. And how about sine theta? Sine is SOHCAHTOA, that means opposite over hypotenuse. Okay, opposite. What is opposite? AY over A. Y over A. So AY, okay, we bring our A to the top, A sin theta. Okay. A normal way, biasanya, okay, zaman sekolah dulu, okay, this is something that always happen to students when they are just memorize. Memorize ni bahaya. Kenapa memorize ni bahaya? Okay. For example, this diagram shows that the angle is at the in between delta x, sorry, in between x axis dengan vector. Dia duduk dekat sini. Ni angle. Okay. But there will be some consequences where we can have an angle over here. Okay. Okay. So saya tunjukkan balik Right. This is AY, A sin theta, AX, A cos theta. Normally itu yang kita selalu hafal ni. Dalam kotak ni dulu, masa zaman sekolah, kita selalu hafal macam ni. What is component of X untuk vector A cos theta. Nah, apa komponen Y untuk vector A sin theta. It's very dangerous to understand like that. Because apa? Sebab angle yang diberi dalam gambar rajah itu, maknanya bila awak nak hafal, awak kena datang dengan gambar rajah sekali. You need to learn in terms of diagram. Sebab angle dia always duduk di antara, angle dia selalu berkaitan dengan ini, berkaitan dengan ini, mesti duduk di antara x-axis, okay, x-axis dengan vektor. Mesti duduk macam tu. Okay. Sebenarnya, angle itu boleh duduk di mana-mana sahaja. Di mana-mana sahaja. Okay, dia boleh duduk di antara y-axis dan juga vectors. So that is very dangerous for us because if for example saya tukar soalan ni, this is vector A, okay, so we always know this one is x-axis, this one is y-axis. So what is the components of if? Nampak? Saya letak dekat sini angle dia. Okay, the angle is that. Okay, so what is kalau kita sebelum ni yang dekat atas tu kita hafal AX mesti A cos theta. Sebab apa kita dah hafal? Mesti kita buat AX A cos theta. Betul ke salah? Dalam kes ini dia akan jadi salah. Kenapa salah? Sebab sokah tuan kita dah bertukar. Nampak? Dia dah duduk macam ni. Orang ni jadi AX, orang ni jadi AY. Apa dia itu cos theta untuk kes ini? Untuk kes ini cos theta dia ialah apa? AY over A. So AY ialah A cos theta. Sin pula? Sin theta will be AX over A. So AX is equivalent to A sin theta. Sama tak dengan yang tadi? Tak sama. Yang tadi AX A cos theta, AY A sin theta. Sebab apa? This is apa yang berlaku sebab kita selalu ditipu dengan angle itu. Okay, ini yang pembaharuan yang saya nak belajar pada kamu supaya jangan tengok kepada, jangan hafal asal dia X dia A cos theta, asal dia Y je A sin theta. Okay, we should look first at the angle. Dia berbeza kalau situasi dia lah dia bagi nilai dekat angle tu. Contoh dia bagi dekat sini dia guna 360 degree. Jadi kita tahu kalau ini dia 90 degree, so dekat sini memang 30. Kan kita tahu ni value dia. Sekarang kalau tak tahu value dia jadi lain. Kenapa? Sebab kalau kita tahu value dia, kita boleh letak dekat sini AX ialah A cos 30. AX juga ialah A sin 60. Nampak? Cuba fahamkan. AY ialah A cos 60 dan AY juga bernilai A sin 30. kedua-duanya betul. Ini betul, ini betul, ini betul. Sebab dia ada nilai. Dia bukan letak angle, dia bukan letak theta tu kan. Ini theta nama dia, theta. So kalau kita tengok pada value ni, jadi inilah the first thing yang awak kena faham mengenai components of vectors. You should know to differentiate between angle and value. You should know the differentiate between because we want to use the Sokatua in this kind of because in here, kenapa saya bagi tahu benda ni sangat penting? Later on, okay, bila awak buat contoh dia, masalah macam ni. Ini contoh dia ada, nantilah awak akan jumpa nanti dalam tajuk force. Okay, bila mana nanti dekat sini mg, dekat sini ada apa, dekat sini ada apa. So awak akan belajar nanti. Kan, dekat sini ada ni n dan sebagainya. So theta tu duduk, theta tu dia bagi dekat sini. Kan, so theta dekat sini bersamaan dengan theta dekat sini. So orang ni akan jadi apa? Akan jadi mg cos theta. Yang dekat sini jadi mg sin theta. So daripada situ lah kita akan belajar, oh kenapa dia cos oh saya mudah saja nak saya macam ni kalau kita confuse macam mana, so the easiest way to understand that kita letak apa value tu untuk sebenarnya awak tengok macam ni awak tengok kalau value if this is the condition, katalah ini vector B, asyik A ni bukan B lah pula kan. Okay, so tengok dekat angle dia, kalau angle dia dekat sini theta, so the bx, ini of course lah x kan, ini x, ini y exist ini exist and then dia punya apa bagi, dia punya komponen dia yang ini tengok angle dia duduk di antara x dengan vektor. Ini vektor yang ada arrow tu vektor lah. Okay, so senang dia bx terus je cos theta sebab dia duduk di celah-celah antara angle tu, this angle duduk di celah-celah antara vektor dan juga x axis. Kalau orang ni dia duduk jauh ke dia ada angle tak? Ada, tapi dalam kes ini dia letak theta saja, dia tak ada value lah. So obviously kalau dia duduk jauh terus letak by sin theta. Kalau ada value lain kalau ada value dia terus kita boleh letak. So we should understand that the cos kita senang nak tengok. Saya selalu ingat macam itulah. Kalau dia duduk angle dia duduk rapat antara line ini dan juga vectors, maka komponen dia akan jadi cos. Yang lagi satu komponen ada tak angle, ada tak theta kat sini? Tak ada. Okay? So dia jauh duduk angle dia, so that's why dia jadi sin theta. Okay, boleh faham? Okay, so given the components of vector, find its magnitude and directions. And vector ni dia tidak akan melengkap tanpa kita belajar components. Belajar component, ini component lah. Okay, this is what we call as component. Okay, and this is what we call as magnitude. Magnitude, and the theta is called direction. Sebab tu dia duduk dalam vector. Okay, we have a component. Dalam jawab soalan nanti kena 3 benda ni. Okay, components, magnitude, and direction. 3 benda. Components, magnitude, directions. So every possible questions about vectors, okay, when we want to solve the problems of vectors, we must have these 3 things: components, magnitude, direction. Components, magnitude, directions. Kalau tak ada, kalau belum ada magnitude, cari magnitude. Kalau mesti dia ada 3 benda ni. Kenapa kena ada magnitude direction? Because this is a vector quantity. Okay, bila vector quantity mesti ada kedua tiga. Mesti ada 2 benda ni, tetapi components ini untuk mendapatkan magnitude. You look carefully. Okay, how to get a magnitude? The magnitude comes from, magnitude comes from A square root of ax square plus ay square. Sebenarnya kalau kita tengok, kita naik ke atas sikit, dia akan jadi apa? A square equals to ax square plus ay square. Familiar tak dengan? Okay. Ax square equals to ax square plus ay square. And again, kita berbalik semula kepada situasi ini. Tengok asal dia mesti datang daripada apa? Mesti datang daripada Pythagoras theorem. Okay. Sebab itulah dia datang dengan keadaan A. Okay. Kalau kita tengok kat sini ialah ay. So dekat sini ialah ax, ax, ay. Okay. So A di tengah-tengah tu. Okay. So ini ialah yang bila kita nak cari dia punya magnitude, well, we can use a Pythagoras theorem. That means yang ini hypotenuse ini kita akan cari A square, yang ni square, yang ni square. Sebab itulah A equivalent to square root of ax square plus ay square. Dalam kes ini ada dua components which is ax and ay. So sebab itulah kedua-duanya di-squarekan, and then of course di-square root back in order to get magnitude. If you look carefully, dekat A yang magnitude ini dah tak ada arrow. Kenapa tak ada arrow? Sebab kita calculate dia punya magnitude. We don't have to put an arrow. Arrow itu menunjukkan dia vektor. That's why kita kena faham vektor yang mana, magnitude yang mana. So yang ini dia akan dapat jawapan macam mana? Dapat jawapan value lah, nilai 10, 20, 25. Dia akan dapat nilai. Okay. And macam mana vektor quantity nak cakap direction dia? Kan sebab kita faham vektor quantity mesti ada magnitude and direction. So macam mana dapat value dia? Value direction dia dapat daripada ini. Theta. Gunakan tangent. Tadi kita dah dapat ini. So nak dapatkan theta ini balik, so gunalah value ini dengan value ini, tangent ay over ax. Tangent theta ialah ay over ax. Dalam kes inilah sebab theta duduk kat situ. Okay. So nak dapatkan theta is tangent -1 ay over ax. Itulah sebab tu dia dapat macam ni. Dia gunakan tangent lah, shift tangent back lah, ay over ax. Okay. So anything kena faham diagram dia dulu. Tengok angle dia. Dia bukan obvious, bukan semua value duduk main hafal cos theta, sin theta macam tu je. It doesn't work that way. Okay. Any question? Ada soalan nak tanya? Sorry.
Tak ada, sir.
Okay. Okay. Now you can use your calculators. Siapa yang ada calculator tu boleh gunakan. Okay. For example, a vector A has a magnitude of 7.25. Find its component for directions of angle 5%, 5 degree, 125 degree, 245 degree, 335 degree. If you look carefully, 5 degree duduk dekat first quadrant. Okay, 125 duduk dekat second quadrant. Yang ni duduk dekat third quadrant. Yang ni duduk dekat fourth quadrant. Quadrant ni apa benda pula? Quadrant lah. Kan jangan lupa matematik awak tu. Okay, first, second, third, and fourth quadrant. Okay, Cartesian coordinates ada fourth quadrant. Maksud dia fourth quadrant number 1 is from 0 to 90 degrees. Itu quadrant number 1. Quadrant number 2, 91 sampai 180 degrees. Itu ialah quadrant number 2. 181 sampai 270 is quadrant number 3. And 271 until 360 that is quadrant number 4. Boleh lagi dia nak pergi. Okay, more than 360. 360 tambah lagi 90, itu ialah quadrant, still quadrant 1. That is how the importance of trigonometry. Dulu kita belajar kan. Kita kena faham. Okay, angle ini duduk dekat kuadran mana. Okay, so this is how it's going to be. Because in terms of components of vector, you should understand that. Okay, kalau kita pakai calculator, exact value, contohnya kita tekan, okay, berapa value dia, senang, straight away kita akan dapat jawapan negatif atau positif. Tapi kalau kita tengok AX dan AY untuk 7.25 5% 5% lagi 5 degree, dua-dua dapat positif. Okay, dua-dua dapat positif. Sebab apa? Sebab dia memang duduk di kuadran 1. Dua-dua positif. Nampak ni? AX dengan AY dua-dua positif. And how about B? Okay. Tengok B. B dia duduk dekat kuadran number 2. Okay. Dia duduk kuadran number 2. Kita tengok AX akan jadi negatif. AY akan jadi positif. Betul lah sebab 125 is like this. Ni 125. So dia ada balance lagi 55 degree. Okay. So AX ini mesti dalam negatif, nampak dia punya direction dia going to the left. Okay. And AY dia pointing upwards. Okay, that's why positive nilai dia positif. So the quadrant akan membuatkan awak verify. Okay. You will check your values either is correct or not in terms of positive and negative sign. Itu penting dia untuk kita faham quadrant. Right? Sebab contoh dia kalau C, okay, kalau C on 245 degree, so both AX and AY kedua-duanya negatif. Nampak? Sebab apa? AX pointing left to the left, AY pointing downwards ke bawah. So dua-dua positif. Dia macam itulah. Okay? Bila dia pointing to the right and pointing to the upwards, kedua-duanya positif. Okay? Bila satu ke atas, satu ke kiri, maka dia akan opposite direction. Vector kan? Okay? And how about vector D? Okay? 335 duduk dekat kuadran number 4. So that's why AX dia akan positif, AY dia pula negatif. So ini penting untuk pemahaman kita lah. Okay? The value itself it will be based on your understanding in terms of quadrant. Okay. If AX is negative 0.5 and AY equals to 1, find A the angle theta. Find A the angle theta. So kita boleh carilah value dia. Ini kita boleh calculate kemudian lah. Because nanti kita kena calculate value setiap satu. Okay, let's look at these examples. Find vector components given the magnitude and direction and vice versa. Okay, find the horizontal and vertical components of D. Okay, 1.00 times 10 power of 2. Okay, tengok betul-betul macam mana dia tulis ni. Kenapa dia tulis 1.00? Maksudnya dia nak, this is 3 significant figures. Okay, is displacement of superhero who flies from the top of tall building along the path shown in figure 3.118. Suppose, okay, this will cari first, find the horizontal and vertical component. Tengok cara dia dikira. Okay, nampak 30 degree 30 degree kena tengok dekat figure. Dia tak ada benda, tidak diberi dalam soalan. Okay, tetapi kita tengok dekat figure dia letak rupanya Superman dia terbang 30 degree ke bawah daripada x-axis. So macam mana kita nak ni we want to draw the component. Component ni mesti datang macam ni. Satu ke kanan, tapi sebab dia ke bawah kan, dia bukan ke atas lah, dia akan jadi sebab dia mesti kedua-duanya. Maksudnya nanti kita akan dapat jawapan AX mesti positif, jawapan AY dekat sini mesti jawapan dia negatif. So kita cuba tengok. Okay, macam mana dapatkan AX? AX A cos theta, sebab apa? Betul lah, sebab theta duduk kat situ. So theta tu 30, 100 cos T. Okay, cos 30. Kalau awak dah faham kuadran, awak tak perlu letak negatif dekat macam ni. Tak perlu letak. Negatif tu boleh letak di permulaan pengiraan. Awak boleh letak di permulaan pengiraan. Tapi dalam soalan ni dia letak di negatif 30 tu dekat angle. In my practice, okay? perspektif saya tak suka letak dekat angle tu. Saya akan confuse. Tapi saya faham that AX itu is pointing to the right. Pointing to the right. Ya, AX ni pointing to the right. So, dia mesti dapat positif jawapannya. And AY is pointing downwards. Bila AY pointing downwards, that means jawapan dia mesti negatif. Betul tak? Betul. Jawapan dia 86.6. Tengok cara dia tulis. Okay. 86.6. This is 3 significant figures. Okay. Itu guna dia kita belajar mengenai significant figures. Bila kita tengok dalam soalan, oh dia bagi macam tu. Oh, that's why jawapan akhir dia tengok. Berapa decimal point semua. Sebab ini melibatkan multiplication dan division. Mesti melibatkan significant figures. Okay. And then the negative 50.0 meters. Okay. Itu ialah untuk AY. Nampak? Beza ada setengah orang kalau dia salah bulan, dia just buat AY equals to A sin theta je. Jadi dia kira 100 sin 30. Betul ke salah? Bila kita buat sin 30 je, memang jawapan dia keluar 50. Sebab dia consider itu ialah kuadran number 1. Tapi sebenarnya dia duduk kat kuadran berapa ni? Dia duduk dekat kuadran number 4. Sebenarnya untuk nak buat ni, dia bukannya sin 30. Okay, dia kena negatif sin 30. Sebab tu negatif tu saya suka letak di hadapan. Negatif 100 sin 30. Jadi angle kita tak kacau lah. That's why kita boleh dapat negatif 50. I don't want to put the negative in front of the angle. But in front of the depan sini boleh letak. Kalau perlu. Then we want to find the leaps in the other direction along a displacement vector P to the top of the platform where the displacement of components are given by Bx equals to negative 25 and By equals to 10. Find the magnitude and directions of the vectors. Okay. So B equals to Bx square plus By square and equal. Nampak macam mana dia letakkan value dia? Negative 25. Okay, kenapa? Dalam kes ini dia buat yang barulah. Okay, dia cari yang baru. Is negative 25 meters based on value yang diberi di dalam ini dalam soalan. Bukan yang based on tadi lah, sebab sekarang ni naik atas balik and By equals to 10 meters. Okay, so cari magnitude and direction of the displacement vector. So now we get 26.9 meters and theta blah 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 dapat negative 21.80 degree. Okay, so don't forget to put the negative sebab dalam soalan komponen dia ada negatif, so you should put negative. Jangan lupa letak negatif pada dalam kes ini Bx tu ada negatif kan. Sebab dia lain soalan A dengan soalan B tu lain. Soalan B dia bagi value dalam soalan A we need to find it on our own. Okay. Alright. So this is how you should know about what is like this. Ini benda yang saya nak mention pada awak sekarang. Tengok perbezaan dua situasi ni. Where this is where the angle between theta is in between vector and x-axis, and this one theta is in between vector, yang warna biru tu vector, and y-axis. Two different things. Okay, dua benda yang berbeza. Ini untuk yang ni. Kalau yang ni dia akan jadi ax equals to a cos theta, ay equals to a sin theta. Nampak nampak macam sama tapi dua benda yang berlainan Sebab apa? Sebab situasi theta tu tidak sama. Nampak? Saya buat macam ni tak sama. Okay, so how to add the vectors using components? Okay, how to add vectors using component? Find the components of each vector to be added. Okay. Ini berbeza sikit. Okay, we can still have time. So, okay, macam mana kita nak tambah vektor menggunakan komponen? Okay, tambah vektor menggunakan komponen. Okay. Right. So, for example, we have vector C. Okay. Vector C ni dapat daripada mana? Okay, kita tengok satu-satu persatu. Vector A, dia ada AX, dia ada AY. Okay. Maknanya vector A, dia ialah datang daripada AX AY. Vector B pun sama. Vector B ada BX and BY. How about vector C? Okay, macam mana vector C? Vector C mesti datang CX campur CY. Macam mana nak dapatkan CX dengan CY? Ini dia. CX ialah AX campur BX, CY ialah AY campur BY. Kalau kita tengok betul-betul, nak dapatkan C mana? Okay, kalau ni secara lukisan dia, okay, vektor A ialah datang daripada sini dan vektor B sini. Bertambah dua-dua ni kita dapat C yang besar ni. Itu ialah CY. Okay, vektor AX di bawah ni. Dan lagi satu, this is B daripada sini ke sini. So the whole thing ialah BX campur AX, so dia dapat CX. So ini ialah CY. So itu secara lukisan lah. So in the end nak bagi tahu, if we want to kita kena differentiatekan X dengan X and Y dengan Y in order to solve the vectors using component. Kita nak solvekan vectors using component ni, kita bahagi dua macam tu. Okay. Okay. So let's look at one example. A is 5 meters. The theta will be 60 degree above x-axis. Dia nampak macam mana dia tulis. Okay. And B is 4 meters. Okay. And theta is equivalent to 20 degree above the x-axis. How about C? How about C? So C itu maksudnya ni nak cari what is the direction, magnitude and direction of C. Okay. Daripada tadi, yang first tadi, yang awal tadi, kita menggunakan graphical lah. Ni. This is graphical method. Kita gunakan lukisan. Kita gunakan ruler and protractor. So, kita dapat 8.75. Data dia equals to 45. This one ialah graphical. Okay. Macam mana nak solvekan soalan ini menggunakan konsep components. Okay. So, first kita dapatkan dulu setiap komponen. Maksudnya, AX apa dia? Right? AX equivalent to 5 meters. Kalau rasa serabut, tak payah letak unit-unit. Unit-unit ni nampak macam menyerabutkan. Okay. Tapi jawapan akhir kena ada unit. Itu penting. Tak payah letak unit dalam penyeraan. Okay. We don't have to put the units where we calculate. But at the final answers, you should put the units. Units is must. Kalau tak, kena potong markah. So 5 cos 60, you get 2.5. 5 sin 60, we get 4.33 for AY. Okay, and BX is 4 cos 20, 3.76. And BY, 4 sin 20 equals to 1.37. I'm hoping that, okay, bila awak tengok saya punya lecture ni, okay, always try on your own. Try tekan calculator. Feel it. Okay, cuba dapatkan rhythm tu supaya awak tak akan rasa gabra bila awak calculate. Okay, try to on your own. Whether you can get that value or not. Sometimes bila awak tekan tu, rupanya awak tak tukar dia dalam mode degree lagi. Awak masih lagi guna dalam mode radian. So dia akan effect lah jawapan awak tu. Okay. Then CX dengan CY, kita dapatkan value dia. CX ialah AX plus BX and CY AY plus BY. So you get 6.26 and 5.7. So in the end, using the Pythagoras theorem, we get C equivalent to 8.47 meters and theta will be 242.3. Tengok jawapan dia beza ke tak dengan tadi. Tadi C equivalent to 8.75 meters, theta equals to 45 degree. Ada perbezaan dia, nampak? Which one is more accurate? Jawapan dia ialah, of course, the components. Because component, we calculate every vectors. We calculate dia setiap satu. And of course, bila kita calculate menggunakan graphical method, maybe there is some error happens during the drawing. Kan? Kadang-kadang kita tersalah angle, kita tersalah measure ruler dan sebagainya. So that's why akan ada error dalam graphical method. But when you use the components, you should get the correct value. Okay, doesn't mean that graphical method is salah. Bukan maksud graphical method is salah. Tetapi kalau tanya which one is more accurate, definitely the components will. Okay, the components is much give you more accurate compared to graphical method. But if the question needs you to answer it in a graphical, you need to answer it in graphical. Itu kena ingat. Kalau soalan dia minta dalam grafik, kena lukis dalam, kena lukis sendiri. Tak boleh calculate guna. Ya, ada setengah orang dia dah mention dah in graphical method, tapi dia pergi calculate. Salah. Dia tidak mengikut orang kata apa? Tidak mengikut arahan soalan. So dia akan hilang markah. Itu saya kena ingat betul-betul. Okay. This is another examples of how you can measure the vectors using components with. Okay. Kalau you all boleh tengoklah dekat sini nanti ya. Boleh tengok. Alright. So saya nak pergi cepat sikit dekat sini. We have another 10 minutes. Okay, maybe you want to go to next class afterwards. So I'm not sure whether you can. Okay. But here, this is the unit vectors. Okay, unit vectors are dimensionless. Okay, ini satu lagi dipanggil unit vector. Okay, that means the unit vector kita nak bagi notation bahawa the unit vector is the vector inside its own axis. Maksudnya ni x yang ada topi, y yang ada topi tu ialah unit vector kepada vector ini. Okay, maksudnya yang ni unit vector pada arah x axis, yang ni ialah unit vector pada arah y axis. Sometimes the questions is given to you in terms of unit vector. Contoh dia, vector D ialah 0i. Dia ada juga guna sistem I ya. I, J, K. Sama juga dengan X, Y, Z. Kalau jumpa soalan dia berbentuk macam ni, this is also a vector. Okay, sebab vektor, tetapi kalau biasanya kita tengok vektor dia dalam contoh A. Vektor A ialah 40 meter to the right. Ni vektor kan. Kalau macam ni dia dah bagi dalam bentuk X axis, Y axis. Okay? Ataupun dalam bentuk IJK. Kalau kita tengok dalam soalan ada OI 22J, 23.5I and negative 40.7J. Okay? If you look carefully, jalan dia sama saja. Yang I dia satukan, yang J dia satukan. Lepas tu dia calculate dia punya magnitude. Dia dapat sekian. Okay. Alright. So I finish about that, and we only left with the dot product and cross product. Okay. Dot product and cross product ni I think kita tak sempat nak ni, tapi you can look at it. Boleh tengok. Dekat sendiri dalam nota yang saya dah bagi tu. Nanti kalau tak faham ke apa pun salah, nanti kita akan bincang pada next class sebelum kita masuk dalam topik next topic. Okay. Okay, until then kita jumpa lagi minggu depan for our next class. Okay, so please nanti saya akan bagi lecture notes pada wakil kelas, and please tolong paskan pada kawan-kawan yang lain. Okay, that's all for today. Thank you very much. Thank you for your